Sen mi şey yapacaksın?
Evet,
Sunumunu.
tam var grubumuzdan. Şivan, Ahmet.
Hello everyone. For this week's KUIS AI Talks series, we have Ahmet Üstün, research scientist at KUIS AI. He has previously earned a PhD from the University of Groningen. His research interests are multitasking, multilingual, and efficient natural language processing, with a particular focus on modular approaches and low resource languages. He's one of the leading members of AI Open Science Initiative. So please welcome.
Thank you. First of all, I'm really happy here to talk. Thanks for inviting. Today I will try to kind of explain our AI project with the dataset and with the language model that we trained with the dataset that we created. But before, briefly, thanks for the nice, kind words. So I'm Ahmet from KUIS AI. Before I get my PhD, I finished, I think, 1.5 years ago, more or less. So I used to work on multilingual NLP with the intersection with adaptation, modularity, and flexibility in general. And at KUIS AI, I'm still working on large language model with different aspects, still including multilinguality, adaptation, different aspects of fine-tuning. Okay, let's get started. So very long story short, these are the result of AI project. So I want to start with that because this was really a long project. It took 14 months. At the end of this 14 months, we had one model we released. We gathered collected very large data set, huge volume and very high diversity. I will try to explain a bit more. This was also possible only with a really large number of people, more than 3,000 more concretely. This includes all the community members that's collaborated for the data sets. In terms of the core team that made the research, also around 100 people, including language ambassadors. So the data set and the model includes more than 100 languages, 101, but with additional scripts actually. So it was really a huge project. So there were lots of difficulties, but at the end we were quite happy what we have. So I will try to share it now. So, but before all of that, of course, I would like to give credits to all the collaborators because this, as I said, this was possible with only many people. That was a huge kind of project. So my plan is like this. I will try to start with some very brief insights about the state of multilingual LLMs. Then I will give more concrete details about the data set, how we collect it, and then how we fine-tune the model, and how we build the model, let's say in that way, and then how we evaluate the model. And if I find time, I will try to touch a bit on limitations or some potential direction for the future works. So I'm supposed to talk, I think, 35 or 40 minutes most. I will try to pack it. If I hit that, please let me know so that I can just skip the remaining part and we can discuss more and I can get some questions. All right. So I think the main question in when we talk about multilingual LLMs, one may directly ask why we are building multilingual LLMs, right? Because as an alternative, we can actually build language-specific LLMs. So in my perspective, these are not like a black and white things. There is no one certain true. I think there are really multiple use cases for language-specific LLMs, but also there are different use cases and different advantages of multilingual LLMs. That's why we focus on this massively multilingual large language models in this project. So what would be some disadvantages of monolingual modeling rather than multilingual modeling? Because when we have a large scale of language coverage, 100, then we need to build 100 different data sets. We need to train 100 different language model. And in total, this requires much more resources, right? Of course, if you compare the performances, there might be differences, but especially if you focus on a very low resource or underrepresented languages, you can probably even not pre-train a language model because there is not enough data sets. So the idea here, train or fine-tune one language model for massive number of languages, like 100. This in total will give you, although you need to have a big language model, obviously, but still in total you have less parameters to train, but also you potentially benefits from cross-lingual transfer or multilingual transfer, especially for the low resource languages, which is quite important and which was one of the main focus of this project. So in general, I'm sure all of you quite familiar with this current set of LLMs, but just to have a complete story here, these days how we build large language models is starting from pre-training, right? Pre-training requires a huge amount of data, much more than instruction or any fine-tuning recipe, and it requires much more resources because you need to train quite a long time. Then this was the first phase, right? And the second phase is instruction fine-tuning, or basically a supervised fine-tuning setup. So we call it as instruction fine-tuning, I think starting from like a GPT, and I think it's like a plan paper, basically, or T0 paper. The main difference for only the difference actually from standard supervised fine-tuning is that the fine-tuning samples are formatted as instructions, because we want to use this large language model like for different kind of text-to-text tasks. So let's say you have sentiment analysis data. Normally in the data set, you would have a sentence and a sentiment label. When I say like a formatting is basically, this is sentence A, what is the sentiment of this sentence? Basically with that template, you can convert this data sample to an instruction and you can fine-tune the model. This is basically instruction fine-tuning. And this requires much less data, and you can train very quickly because that doesn't require also that much of training steps as well. And the final step after this is what we call reinforcement learning from human feedback or preference tuning. This is also a different kind of supervised fine-tuning, but this time it's not instruction and the generation, but this time we try to fine-tune the model based on human preferences. Could be like a data pair for one prompt, or there are different ways to do that actually now. But in the project, what we focused was completely instruction fine-tuning, because when we want to scale the language coverage for a data set and then the model to hundreds, pre-training is really like a super costly. You need to like build a huge resource to be able to do that. But for instruction tuning, this gives a huge boost, but also it requires relatively less amount of resources. That's why we focused on instruction fine-tuning in the project. I can pass this part. So I think it's just the time here mentioned. Since we focused on instruction fine-tuning, we of course started with a pre-trained model. Our pre-trained model to start with was MT5. So this also another question, like, because when we explain about the project, people ask us like, why MT5? Because this is like a language model from 2019. It's not one of the strongest model at all. But since our main focus was the language coverage, we want to build something for like 100 languages. The MT5, interestingly, is still one of the best generative model with that language coverage. There is no other like open source language model with the similar language coverage. That's why we started with MT5. Like the thing that I was going to say at the end, one of the limitations is indeed this one. If you have a better pre-trained language model with similar language coverage, probably the resulting instruction fine-tuned model would be much better. But this is what we had, and we started with MT5. More concretely, for the like a background in terms of multilingual instruction fine-tuning, general trend here is take a strong pre-trained multilingual language model, fine-tune it with the English data. For example, in the case of Poem, which is not open source and which is quite big one, very powerful language model, potentially fine-tuning only English gives a certain amount of performance in terms of some different languages, which is kind of surprising, but this is kind of has been studied for a long time, this basically cross-lingual transfer from English. But when you don't have such a strong language model and when you want to scale the language coverage into 100, this method doesn't work, because even if you can get some performance from English, you still need to have a certain amount of data for each target languages so that your model learn a bit of on this language as well. Although maybe some task information coming from English or some diversity coming from English data, still you need to have a multilingual data. At least this is what we kind of observed throughout the project. Most similar work, which was also the baseline when we started, was actually something called XP3 in terms of the data set and the MT0 in terms of the model from Mühlenhof. So this actually it's a really nice work. They built a multilingual instruction fine-tuned data set and fine-tuned a pre-trained model with this data, end up with a multilingual model. I will show a couple of limitations of this data, but this was our starting point. So this is XP3. So it has certain disadvantages or limitations. I think the most important limitation is 40% of the data is English. So this already shows, okay, this is the multilingual in a certain degree, but not that multilingual, not how we want that. But another super important limitation is XP3 is based on mostly discriminative tasks. So as I said, like you can convert sentiment analysis data to an instruction. You can fine-tune your model with this instruction, but your model will learn mostly answering very short, giving very short answer like yes, no, or sentence A, sentence B. This is what we have seen in MT0 model. Although the model is multilingual and the underlying model, MT5, is kind of generative model, but the model does not really learn generating relatively longer sentences, but mostly learn on answering with a discriminative manner. So seeing this data set, when we started, we target, okay, we want to build more natural multilingual data that has some discriminative tasks, obviously, because this increases the diversity, but also has more generative and organic instruction from target languages. And also we want to have a bit more balanced ratio in terms of language coverage. From MT0 to AYA, there are a couple of models actually presented by the community, research community. These are like Okapi or Bactrian-X. These are mostly based on strong language models like Llama. Llama is not really a multilingual model, but has a certain degree of multilingual data set. That's why it learns a bit, but doesn't really learn that much. And their data set is mostly based on translation. So, but still in the evaluation I will show, we compared our AYA model with also Okapi models or Bactrian-X model together with MT0 or Bloomsy, which is both fine-tuned with the XP3 data that I just showed. So yeah, basically this AYA model, in general AYA project actually, is a combination of a huge volume of data. I will give the details, a fine-tuning recipe in terms of the multilingual instruction tuning, and a very extended multilingual evaluation. So I will try to touch all these three different points now. For the AYA dataset. So I keep saying AYA dataset, but actually AYA dataset also is a combination of three different components. These are AYA dataset itself, AYA collection, and we also release an evaluation suite for the generative evaluation, which we call AYA evaluation suite. These different components includes human annotation, completely human-created data, which is this AYA dataset, more focused on the collection and editing, quality checking, and translation of the existing dataset, which is AYA collection, and evaluation. I will give some details. This is mostly post-edited or human-edited part of some datasets. Before all the details, this is more or less how AYA dataset and AYA collection looks like in comparison with other datasets. So one nice thing is this is the best, I mean, if not the best, it is the largest multilingual instruction collection data. It is really huge volume, which is definitely an advantage. AYA dataset itself, this is the smaller part, only 200K, but this is completely human created. So this is mostly very high quality data samples. And one more thing that worth to mention is the license, because AYA dataset and collection is completely released with the permissive license. So because we want to release something, I mean, we built something with all the people, more than 3,000 contributors, and we want to also give it to the research community in that way. So first part, the AI dataset. I say this is human-created data, right? Here, actually, I want to show how we created this data. There were two different ways to create data. How we started was we first pick a dataset from XP3, translate it into 100 languages, and then put to our UI, and let our community members to edit prompts or completions. Because XP3 was not really generated by humans, because it was mostly using an English prompt and then picking a multilingual dataset. But here we want to have more natural kind of instruction. And the first way to do that was human edited. Right? This was like a one task. After like I think a couple of months later, for first task, we initiated a second task. Second task was directly writing prompt and completion in an organic way. So our community members log into the web UI, put prompts and completion in their own languages. This was a second way. I didn't put here, but actually to the end, we maybe after the halfway, we had another task, which is more like a checking the re-annotations or organic prompts, because this is the only way that can we look at the quality of the data. Although we probably didn't look at all the data, because like millions of data points, but we try to understand how like an original data set and the re-edited data set changed, but by looking at the edit distance. But also then we want our community members also kind of confirm, okay, this data set is the data sample is edited, and this is good. If it's not good, re-edition of the edited data. So that was the way we kind of at least have some sort of sanity checking in the data. This plot basically shows like a distribution in terms of the contributions. So since our like a community, Cohere for AI community, like has lots of people from different countries, more concretely 119 countries for this dataset collection. We have really large like and wide distribution from different countries in 65 languages. Second part is IA collection. So as I said, IA collection is not designed for like a complete and natural and organic instruction, but the design perspective was slightly bit different. Here we want to increase the diversity, because when you use the existing data set, it might not be the most high quality, but still you can actually have a different categories of task, which has been shown that it's quite important for the instruction fine-tuning. The problem was there was not much like a multilingual dataset in that context. So what we did was two things. One, the translation, but before the translation, we carefully picked these datasets, because if you only focus on the descriptive task, as I said, probably you cannot have a good dataset. Also, you cannot use this dataset for like a good generative model. We want to balance descriptive task together with the generative task. For example, we looked at the prompt and completion length when picking the dataset. And since we had like a lots of community members from different languages, they looked at language-specific dataset to understand the quality. After this quality check, we use an automatic translation model, open source NLLB from Meta. 3B size version we used, because this was the best in terms of also the the cost trade-off. And using 3B NLLB, we picked the data set into 100 languages. Of course, just before translation, of course, we still use a transformation from like dataset format to instruction format. The nice thing is, since the people from the community members and our research team built this, looked at this data quality, also we built the templates as well. So templates are not English templates are created and translated into different languages, but templates were created manually. But then we translated the formatted data into multiple languages. So in the table, I give a couple of task categories here: summarization, translation, paraphrasing, dialogues, or text simplification. These are more like a generative fashion task. We have question answering task as well. And then that more descriptive fashion mannered text classification tasks like sentiment analysis, information extraction, natural language inference, and this kind of tasks. But the main priority, although we use translation, still keep a high quality prompt and completion pairs. So this is an interesting plot. So in the bars, we actually looked at the distribution in the Wikipedia for different languages. So that's why one like a y-axis has different numbers in left side and right side. So it's not like a head-to-head comparison, but we want to have a comparison in terms of the distribution. In Wikipedia, if you, as you can see, the distribution is extremely skewed. But for the, sorry, not one, but the green line. But in our IA data, the distribution is not as skewed as Wikipedia because we kind of focused on having high quality lower source language as well. This was kind of showing that we have a more balanced and potentially nicer distribution in terms of lower source language representation. Final part of the dataset is the evaluation suite. So here, there still, I think in the community, there is one gap. Where if you have a generative language model, how you evaluate this model is really a big question. I mean, we cannot answer this question here, but one way to do it is you have a prompt and completion pair, more generative fashion, more like a more natural instruction, and you can compare different models completions by using another human annotators, professional human annotators, or maybe another language model, right? This is one way to do it. But even for this scenario, when we started to evaluate language models with baselines, we couldn't find any evaluation data set for this purposes. That's why we also built more carefully picked high quality data sets, mostly translated from Dolly 15K into different languages and then human edited or directly also the IA. So one is the human edited Dolly translations, other one is directly the IA dataset, some portion of the IA dataset as evaluation data. This data is basically includes only prompt and completion, but more important is actually, so you can use in two different ways. You can use prompt, you can prompt two different models, compare their outputs, or you can prompt one model, compare the original generation with the model generation with different weights. But this kind of allows us to compare different multilingual generative models. I cannot see if there is any question or anything. I can continue, or if there is some question, I can also try to answer here. How would you like?
Ahmet, hi. I want to ask a couple of questions. Okay, first of all, have you annotated or edited examples for the training split? Because you were talking about re-annotations of the examples in the UI part, I guess. That's my first question.
We actually annotated, I think here on the training splits, because I mean, all this data goes to training data as well later on. But for
you also re-annotated them, right? And used in the training.
Yeah.
Okay. The other thing is that why did you select the Dolly as the validation data set? And how do you evaluate the generations? Because the Dolly is, I don't know, but it should be the only data resource instruction tuning data set that is, I mean, clean. For instance, that Alpaca, it's collected from the, GPT-4, I guess. I'm not exactly sure, but Dolly is the most clean one, right? And
so
people
your
use,
question is not why not we did not use in the training but use it for validation. Is that what you want to ask?
Yes, because it's very when in comparison to the other instruction tuning data sets, it's very clean, high quality data set. I understand that it would be good for evaluation, but it would be good for instruction tuning also as well.
Yeah, that's a really good point. Indeed, we did not use only for validation. We separated 200 examples from Dolly. We only use these 200 examples for evaluation. And the other part, actually, we kind of even updated this part because of the reason that you mentioned. It's a clean, completely human created data set. It has all different kind of task categories inside as well, more instruction formatted, very natural, but also different task categories. So we used in the training too. But the training part is complete the machine translation. So there is no human addition involved there because of the amount of the data.
Okay, my other question is that how do you evaluate the models using the Dolly instructions? I mean, do you perform human studies?
So yeah, exactly. What we did, we prompted two different models. Let's say we take MT0 and I will explain a bit more, but IA model, get the completions from two models, show humans which one is better. If both are like equally good or equally bad, tie, otherwise pick one of them, like kind of win rate. We did this for certain amount of languages, but of course we didn't have like for large amount of languages, professional human annotators. But also we did the same thing with using GPT-4, looked at the correlation. Correlations generally has really both have like a above 80% correlation. So for some languages, we only have GPT-4. For some other languages, we have both human annotation and GPT-4 annotation.
I see. Thank you very much.
Nice. If there is nothing more, I can continue, but I would like to get the question on the way. That's completely fine with me.
There's a question in the chat, I guess.
Okay.
Doruk is asking about the, I would like to learn about the hardware or platform used for training.
Okay, I will take this question and will answer when I am explaining more fine-tuning details. I think that would be more fitting. All right, for the IA model, I will also come to how we trained it. But even before, I think more like a more conceptual question is, especially in the case of multilingual fine-tuning, multilingual instruction tuning, how you create the data, how you balance data. I think this is the most important question because it's not as straightforward as you take Dolly data only for English, fine-tune the model, because then you don't have much of a concern in terms of the balancing or different categories and stuff. Still, it is a concern, but not as much as in the multilingual setup. That's why in fine-tuning, this was one of the part that we kind of really focused, having as much as diversity from different tasks, but also having as much as diversity in terms of different languages. So it's kind of two-faced kind of problem. That's why we use lots of different data sets. This includes, of course, this built on top of IA dataset and IA collection. These are more like a kind of high quality, especially IA dataset. IA collection is more focused on diversity, but still we did not want to stop there in terms of the diversity. We added an extended version of XP3, which we call it XP3X, because XP3 was for only 46 languages. We extended this to 101 languages at the beginning. Then we pruned XP3X because it has lots of repetitive templates. So dataset, let's say, has 100 million samples, but maybe half of them was very similar templates. So data points were quite similar. That's why we pruned that as well. And also we use something called data provenance collection. This is a collection of dataset that is completely permissively licensed, but mostly on English and mostly on discriminative tasks. So we used a subset of data provenance collection in our instruction mixture. For the automatic translation, this actually a part of IA collection. That was the point that you asked. We used Dolly 15K, and we used something called shared GPT command. I will come to that point. This is also quite similar in terms of Dolly, but also we translated different kind of dataset. This includes Flan collection or Mintaka, and there is like almost 20 different dataset that we translated in IA collection. So this shared GPT command is kind of special because although we combine all these different data sources, we were still kind of missing high quality generative fashion dataset, and we want to use something in that line. Shared GPT data is actually very fitting for that purposes, but the problem with the shared GPT data is the completions were generated by GPT, ChatGPT or GPT-4, which is not permissively. I mean, if you want to release something with the permissive license, I think you cannot use that. I'm not sure about the legal gaps, but still we did not want to do that to respect their use. What we did, we take the prompts from shared GPT, pass these prompts in English on Cohere command model, the largest Cohere command, which was quite powerful. It's now even more powerful, but at the time it was still very good. Get the completions on English. Then we translated this English prompt and completion pair to all the languages with the same system, so that we have this shared GPT command. So you may want to ask, like, what about the permissive license case here? So we get a special case so that we, since from the Cohere, that we can just use it and release not the data set, but at least release the model with permissive license. That was the approach that we kind of followed there. But this is slightly bit different from all others because this is based on sort of instruction, synthetic instructions, which is kind of popular these days. And it works quite well as well. Here there are some like comparisons, not comparison, but like some stats in terms of different data sets with the high resource language, mid resource languages, low resource languages, also like a different lengths. The important thing is here, our translated dataset and AI dataset has quite a good percentage of low resource languages and also mid resource languages compared to high resource. But the above dataset is they are more like a discriminative fashion. They are more in high resource dominated datasets. Another important stats here is the average target length, because some dataset like data provenance collection, as I said, these are really focused on discriminative tasks. That's why average target length is very short, but this is not what we want to have. That's why, for example, if you look at the ShareGPT comment, average target length is much longer because this is actually what we want to combine when we are fine-tuning the model. This is exactly what I was saying in terms of how we balance this. So we actually tried different balancing strategies here, and we present them as like ablations. One is called, we call it translated heavy. This here we upweighted translated datasets, because if you look at all the red bars is natural distribution of the data. English percentage is around 20%. When we upweight the translated data, English percentage drops to something like 8, which is good because most of the diversity still comes from English. We don't want to use like a 1% for all the languages. We want to still use a higher percentage for the English. But this is what we did for the translated heavy ablation. For the templated data upweighting, this is called templated heavy in other plots, if you see. So this is more or less fitting the natural distribution. So we just used like upweighted the templated data, but keep the slightly lower percentage for other datasets. And just for like an experiment, we also upweighted the AI dataset here. But as you can see, the problem, first of all, AI dataset language percentages are not uniform. That's why some languages, like let's say Kyrgyz, gets quite high percentage, but some more languages having a more diverse dataset gets downweighted. And English percentage also around like 80. And since this AI dataset has only 200K samples, and we trained the model for like a sample budget of 25 million, when we upweight the AI dataset, actually this AI dataset has been seen for like maybe 60 epochs, which is not really good. That's why AI dataset variant is not the best variant, but still we want to experiment with it. So I will show some results, but before, as I said, important part of the project, and especially modeling part, was the evaluation, because this is really very troublesome or very challenging part in terms of the multilingual generative languages, multilingual generative language models. That's why we combine different class of evaluation data. So one part is we call zero-shot unseen task. So the thing is here, this task as a task category, for example, XNLI is natural language inference. We did not use any natural language inference dataset in the training. So regardless of the dataset itself, the task category is completely unseen in the first part. And we use zero-shot prompting. Second part is MMLU. We used a translated version of MMLU, translated by another research lab. It's called Okapi. The paper name is Okapi. We use the standard 5-shot prompting for MMLU. This is not an unseen task, because basically this is a multiple choice question answering, and we use multiple choice question answering data in training. But the MMLU training set was not seen during the training. So dataset is unseen here. For the generative task, because this is another focus that we want to achieve here, right? We want to see generative performance. We looked at, first of all, standard generative performance, like translation, summarization, or question answering, but in a generative fashion. With the AI eval suite, like a DOLI evaluation or a human-created AI evaluation suite, we looked at win rates. And also we experimented with different safety measures. If I find the time, I will briefly mention. And we kind of evaluated how safe is kind of ambiguous term, of course, but based on the metrics that is defined, we looked at safety, toxicity, or bias measures with the models. And these are the baselines that we compared. So as I said, the strongest baseline when we started was MT0 because this is largest model in terms of the language coverage, but also in terms of the strongest model in terms of the performance. If you look at the benchmarks, the Bloomsy is another one. Bactrian is not as strong as MT0 or Bloomsy, but still we want to compare because it's based on Llama, especially on English, it works much better. Okapi is another one. It's a set of language models, actually, not one language model. But the problem here, none of them has 101 languages. So when we compare, it's not like a apple-to-apple kind of comparison. That's why we extended MT0 with XP3X, which has 101 language coverage. Because MT0 was pre-trained with, fine-tuned with XP3, we just used XP3X to fine-tune MT5 and created another variant of baseline, what we call MT0X. Has 101 languages and similar characteristics with MT0. So for the first task category, so there are lots of numbers. I will try to make it very quick and just try to give the main message here. The one thing that is kind of interesting, although like IAMADAS works pretty well, main comparison is MT0, and the point that I want to mention, MT0 includes only 46 languages during fine-tuning, but IAMADAS includes 101 languages. Although it has more languages, which kind of creates another challenge for the model to learn all the languages, still it is quite good, and in most cases it outperforms MT0. But another perspective to look at these results, MT0 are still quite competitive. Although we add all these different tasks, MT0 is pretty good. This is because MT0 or Bloomsy was mostly designed with this discriminative task perspective. All the data set in XP3 or XP3X was discriminative tasks. That's why it's quite competitive. But when we look at the head-to-head comparison with MT0X, now we have the same number of languages during the fine-tuning. And there's a quite important gap between IA model variants at least, and MT0X. So there is one star in IA translated heavy because this is the model that we released based on also the other evaluations that I will show. So this is multilingual MMLU performance. So very shortly here, multilingual MMLU is a discriminative task, but it's a bit more measuring general language understanding performance, which also I think the result that IA model has considerably better performance even compared with MT0 here. These are the generative task performances. So it's not unsurprisingly, our IA model translated heavy variant performs pretty well on translation. This is not because model have more translation dataset, but model has lots of translated datasets that allow model to learn target languages much better, especially if you look at the English to X case. The difference is not as much as X to English in terms of like absolute difference, but if you look at the relative gain, because it's from 14 to 19 is, I think, quite good relative gain compared to MT0X. Another thing, just briefly mention why we did not include MT0 or Bloomsy in this evaluation. This is because MT0 or Bloomsy trained with XP3, which includes all of the validation and test data for this Flores or XLSAM or TiDQA. That's why we did not put that. But when we are training our model, we filtered out the validation part and test part of these datasets, and that's why it was possible to evaluate on those. Very briefly, not this time, not on the particular task, but I would like to show more in terms of how this performance gain happens in different language groups, high resource, middle resource, or lower resource. And in terms of the relative gains, actually IA models as a kind of what we wanted to have better relative performance gain on low resource languages. This is really important, especially if you look at like a Flores gains in the lower source languages, it goes from like a 15 to 26. So this is really important, almost like a double gain for the lower source languages. Also kind of show how the data set that we kind of created is important for this kind of tasks. I think this would be the last one. Then I want to maybe briefly summarize and go for the question. But this is the open-ended generations that is we kind of really focused here, because we also wanted to understand, although even all these models not like a best, not like a GPT-4, but still we want to see some sort of how useful these models might be. When you compare with MT0 or MT0X, because of this discriminative generative task asymmetry, AI models has extremely high win rates, because MT0 or MT0X really does not generate much except very short completions. Another interesting point when we compare with Bacterian X here, but as I said, Bacterian X was based on Llama 13b, which is quite a strong language model, right? But it mostly focused on English. So it's an English language model, let's say. Although in the paper they present Bacterian X, they fine-tune with the multilingual data, except the English, AI model still highly outperforms Bacterian X. But in English, Bacterian X outperforms AI model. I think this is something expected, but also kind of shows the difference between AI model or Bacterian X model here. Yeah.
Can I say one thing regarding that? Maybe it's not a fair comparison, because I also read the Bacterian X paper, and they only use the Alpaca and Dolly instruction tuning datasets. So they are training, but they still use the Llama backbone.
Yeah, but they translate the prompts or for Dolly or Alpaca dataset, then prompt to GPT, ChatGPT on all these different languages, for I think 52 languages. So they build a dataset that they call like bacterian data. This data is uniformly sampled from 52 languages. So the fine-tuning time, it is completely multilingual, but the difference is really exact here. Although the dataset is kind of multilingual, the model is not that multilingual. It's really high performant in English. That's why it's completely normal that in English it works much better, right? Because this is a design perspective. But it was different.
But it's a very good finding also at the same time.
Yeah. Thank you for that. Okay, I think I kind of mentioned these parts. So for the safety, I will share the slides because I think now it's better if we discuss if there are some questions. If there's no, I can go for the safety part. But I mean, I will share the slides, and anyone can just directly contact with me if there is any question or any discussion, open questions about this part. Maybe very briefly, I can look at these parts very quick. So what we kind of found at the end. So we released the largest instruction tuning data, also multilingual, massively multilingual, and AI model. These are all publicly available now on Hugging Face. But still, there are multiple limitations. As I said, the main, I think, in terms of the modeling perspective, the main limitation was the pre-trained model, because we start with MT5, it's not the best model. Also, if we have a better pre-trained model, then we assume that, or we kind of expect that the performance of fine-tuning with AI data would be much higher. Also, so we had to use certain type of definition for different languages, because this was mainly a data collection project at the beginning. That's why there might be even more comprehensive look in terms of the research perspective for the language definition, in terms of language groupings or dialects or code switching. These are really important. Still, although we had a high diversity in terms of languages, this is still limited, because I mean there is much more languages than 100 languages, and this data is mostly from a global north. Because I mean diversity comes from English, right? This is another super important gap that we partly touched but couldn't fill here. I kind of passed this safety part, but the main message was in the safety part was we applied a couple of safety fine-tuning, which highly improved models' performance in safety evaluation, but at the same time, it kind of decreased models' general performance a bit, which is the problem. So I think this is something that people should look at in the future for the future work. How to make multilingual generative models more safe. It's really, really important and open questions. And of course, evaluation is. I think this is the one of the most important question, not only for multilingual LLMs, but general for like a generative evaluation. And we kind of try to have an extended evaluation here, but there is still much more thing to do in terms of the future work. So I will start the question answering session by answering the question. So we use TPUs because MT5, so MT5 also available in Hugging Face for the PyTorch, but we had like a TPU resources. Then we use a framework called T5X, which is very easy. I mean, it's not easy to customize, but it's very easy if you just want to use it like out of box. And it's very applicable for the TPU clusters. That's why we use T5X with the TPUs. In terms of the training details, as I said, our training budget was 25 million samples. Although the dataset was like more than 500 million, of course, we couldn't use all of them. But this is interesting because normally for English-only language model fine-tuning, normally you don't use that much of samples during the instruction training time. But for the multilingual language models, and if you want to make it for 100 languages, our observation and our finding is we need to still train quite long, which is like in our case, we use a budget of 25 million samples in general. Yeah. I'm happy to get any question, any feedback, and any discussion.